Hello and welcome to Audrey the ICONN Adventures. This is video number 3 in a short series about the operation of the Manager 30, especially interacting with charging from your tow vehicle. You can see here on Audrey we have the standard Manager 30 display and it's showing 94% full with an hour to go. We're making about 18 volts from the solar, about 120 odd watts. We come down another step and we've got about 8 amps going into the batteries at the moment. And over here on the voltmeter, it's flickering away and that's 13.7 volts. So thinking about what we saw in the first video, the batteries were full, the solar was holding it there. So with the car connected and running, the Manager 30 was showing about 14 volts, which is basically the output of the alternator. And it was showing that because there was no load on the alternator from the Manager 30. In the second video, we had the batteries depleted down to about 93%. So they were wanting to pull current to charge back up. The solar was pushing out approximately 7 to 8 amps. So then when we connected the car up, it took the Manager 30 out most of the way to max. It took it up to about 28 amps of output. So we have to allow 20 amps as a rough number coming from the car to charge the batteries. When it was drawing that 20 amps, the voltage display on the Manager 30 for the input into the Manager from the alternator was down to as low as about 12 volts. Now you might think, wow, that's a 2 volt voltage drop and that's quite excessive. Well, reflecting upon the setup that we have here, we've got approximately 6 meters of cable being both positive and negative coming from the battery at the front of the tow car all the way through to the hitch. And then there's approximately another 5 meters in the revamped, and I mean majorly revamped, version of the wiring in Audrey here, and that's about 5 meters each extra of positive and negative to get into the battery box and to the Manager 30, making approximately 11 meters on the positive and 11 meters on the negative run. Apologies for this being a bit blurry on the computer screen. Anyway, I looked up the details for the cable I used in the car, and that's this right here, and being 6 BNS cable. And the important thing we're chasing here is the 1.4 ohms of resistance per 1,000 meters. Then the calculation to work out what sort of voltage drop you could expect to see is right here. Basically, it's the old V equals IR, being volts equals current times resistance. So we know our resistance is about 1.4 ohms per 1,000 meters, making it 0.0014 ohms per meter. We've got 11 meters as a one-way run, and we're running about 20 amps. So off to the calculator, we go 20 amps times 11 meters times 0.0014 ohms equals about 0.31 volts in one direction of voltage drop. What we need to remember here is that 0.3 volts is just for one length of cable getting from the alternator to the batteries. Because we then have to come back via the negative, that doubles it up to about 22 meters of cable run for this car to charge the batteries in Audrey. So that would take it up to about a bit over 0.6 volts of voltage drop at 20 amps. Obviously, the more or less current that you have flowing will make more or less voltage drop. So when the Manager 30 was showing approximately 12 to 12.5 volts when being fed by the vehicle, that is measuring the alternator minus that approximately 0.6 volts to be the actual input coming in into the Manager 30. Then we may have a little accuracy discrepancy with the Manager 30 and the actual voltage coming out of the alternator at that point in time I was not measuring. So that still has me feeling that the size cable I have is the absolute minimum I'd want to have, and that's 6B&S. The data that I was using for the calculation, that is for the cable that I've used in the tow car. It is not the cable that is in Audrey. That is the as supplied cable. So it may be better cable, it may be worse. There's no way of knowing. So that will give you a bit of an idea of what a modified wiring setup in an E2 will do. For a standard E2, you can expect that 0.6 volt voltage drop to be significantly higher because you've got approximately, believe this or not, 12 meters more cable run with all the carry-on of the way the cables are set up in a standard trailer. So that would nearly double your voltage drop. I'll be generous and say you end up with at least 1 volt of voltage drop at 20 amps with a standard E2 using 6B&S cable in your tow car and making sure all the connections are as good as they can be. I hope this provides a little bit of insight into how the Manager 30 works with your tow car and the sort of numbers you can expect to see. These are real world, no theory here. And you could see that the Manager 30, because it's got pure sunlight up on the solar, it preferences the solar power first before it takes the power off the alternator. So that 28 amps we saw in video number 2, 8 amps of that was coming from the solar panel, and therefore only about 20 was being drawn from the car. Thank you for your patience with this very long video, and if I got anything wrong or you'd like to know more, please do let me know. Thank you.